Okay, I think we have 5 points. We have 1, 2, 3, 4, 5, 6 templates. 6 templates. You guys ready to go? That's what happened. Okay, here we go. We're going to go over the SOHCAHTOA from geometry. Didn't you guys have SOHCAHTOA in geometry? Guess what, you guys? It changes in trigonometry. You're going to learn this for about a couple days, and then we switch to what trig teaches. So this isn't what trig teaches, but they want you to get used to how to find SOHCAHTOA. So we do not learn on floating triangles. Do you see that this is a floating triangle? What does floating triangle mean, you guys? Geometry teaches floating triangles. We don't teach on floating triangles. We teach, this is geometry. Trigonometry teaches on an XY coordinate plane. That's what we teach on. We teach on quadrants. Quadrant 2, quadrant 1, quadrant 3, quadrant 4. Before we switch over to trigonometry, we're going to review geometry, and we're going to just work on floating triangles like you had in geometry, right? Floating means just a triangle. SOHCAHTOA. Cool. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. This is the angle we are talking about right here. Isn't this side opposite of that angle? Isn't this the hypotenuse of this triangle? And if this is the opposite and this is the hypotenuse, isn't this the adjacent side? Adjacent means next to, right? I live in the adjacent house. I live next to that person. They use adjacent all the time. Adjacent means next to. So, sine is opposite over the hypotenuse. So, cosine is adjacent over hypotenuse. SOHCAHTOA. SOHCAHTOA. Again, all of these are going to change on this very quickly. Right now, we're just going to review these, but the formulas are going to change. I'm going to give you a gigantic formula sheet for trigonometry. Do you notice that there's 3 other trigonometry formulas? Do you notice that these 2 are reciprocals of each other? If sine is O over H, cosecant is H over O. Cosine and secant are reciprocals of each other. Tangent and cotangent are reciprocals of each other. Yes, you have to memorize these. I like to remember that this one ends in the S, this one starts with the S, so that they're reciprocals of each other. Tangent and cotangent are very easy to remember, right? Tangent and cotangent are. These 2, though, you could get these mixed up. So I like to know that cosine ends in S. Its reciprocal is the one that starts with S. That's what I've always remembered from when I was in high school. I don't know how you want to memorize them, but you need to know all 6 trig functions. Take out your calculator really quickly. We're going to use a lot of these buttons on your calculator. Do you see the sine, the cosine, and the tangent button on your calculator big as day? Everybody see the sine, the cosine, and the tangent button? Do you see above the sine, the cosine, and the tangent button is sine -1, cosine -1, tangent -1? Those do not stand for these. They do not stand for those. That's a totally different thing I need to teach you, what the sine to the -1, cosine to the -1, tangent to the -1. Those are totally different things. Where do you find these buttons on your calculator? You know where you find these buttons on your calculator? I told you in college algebra where to find those 3 buttons on your calculator. This button right here is a really, really, really important button on your calculator. That's called the reciprocal button. What is x to the negative 1? I hope you know what x to the negative 1. A negative exponent does not give you a negative answer. What does a negative exponent give you? Starts with an F. What does a negative exponent give you? A fraction. What is x to the negative 1? 1 over what? 1 over x. So, if you want to get to this button on your calculator, you need to go through this button on your calculator to get to this button on your calculator, correct? You need, if they ask you to find, let's just do it. Let's find the sine of 50 degrees. Everybody find the sine of 50 degrees. I gotta check to see if I'm in radians or degrees. Okay, okay. Sine of 50 degrees, you guys. What's the sine of 50 degrees? 0.7660. Is that what you guys got? The sine of 50 degrees, the sine of 50 degrees is 0.7660. Everybody got that on their calculator? Now, I want you to find the cotangent of 50 degrees. I need you to find me the cotangent of 50 degrees. There is no cotangent button on this calculator, is there? What do we have to go through to do cotangent? What's the reciprocal of cotangent? What's the reciprocal of cotangent? Tangent, right? So don't we have to do the tangent of 50 degrees on your calculator? So do the tangent of 50 degrees on your calculator. Is that the answer, 1.19 something? Is that the answer to cotangent? No, that's the answer to tangent. How do we flip that so that we take the reciprocal of that? Can't we hit the x to the negative 1 button? That will flip it. Answer negative 1, the cotangent is 0.839. Got it? So, that x to the negative 1 is a very, very important button on your calculator. That flips things. Really important button. Okay, moving on. We talked about the formulas. We're good. Okay, moving on. Part 1, starting the parts already. They want you to find the cosine of alpha. They want you to find the cosine of theta. Like I said, we're doing Greek letters. They want you to find the cosecant of alpha. So, here we go. What I would do to understand this is I would write the formulas first. So you get these formulas down in your head. Isn't cosine cos? What's cos? A over h. And I would write that down. Again, cosine A over h. Write it down. Cosecant. You guys know what that's the reciprocal of? Cosecant is the reciprocal of which one? Sine, right? Isn't sine so over h? Isn't it h over o? H over o. You need to start memorizing these formulas. Start memorizing these formulas. But again, they're going to change on us once we get to trigonometry. So, here's alpha. Here's alpha. Not the alpha. What's the side adjacent to it, and what's the hypotenuse if you're looking at alpha? What's the one next to it? The 8 or the 17 is next to it? The 8. What's the hypotenuse in this picture? 17. Final answer. I know you did this in geometry. I know you did. What's the cosine of the theta picture? Well, here's now the new angle theta. Cosine is adjacent to it. Which one's adjacent to theta? 15. What's the hypotenuse in this picture? 17. And now the cosecant of which angle are we talking about in this problem? Alpha. We need to go back to alpha. We need to know what the hypotenuse is. What's the hypotenuse of the picture? 17. What's the opposite of alpha? 15. Final answers. It's going to get harder and harder. Wow, they gave you all the information on the triangle. What do you think the next section's going to be? Not all the information on the triangle, right? I think that's what we're doing in part 2. No? Let's do the next part. Next part. Part 2. If the secant is 6 over 5, what's the cosine have to be? Are these two reciprocals of each other? Does it end in s and start with s? Are they reciprocals? So on the ACT, I think they're going to give you one like this. How long should it take you to do this problem? 5 seconds, right? If the secant is 6/5, what's the cosine? 5/6, right? This should take you the 5 seconds on the ACT. Believe me, those last 10 problems on the ACTs are killers. They're going to take long to do. They're going to take 3 minutes to do. A lot of you won't even finish the ACT questions because those last 10 problems are buggers. You need to get through the first 20 problems way faster in less than a minute a problem, right? Less than a minute a problem if you want to finish 60 problems in 60 minutes. So you need to be fast. This one should take at least 5 to 10 seconds to do, right? To save some time to do at the end, where you need 2 to 3 problems to finish. So, if the sine is 4/5, what's the cosecant going to be? Are they reciprocals of each other? What are they going to be? 5/4? Do you know what we do right before the April, what is it, April 23rd, April 21st, you're taking your ACT, I don't know when it is, April 19th, something like that, right, you guys? I stop everything in this class for a full week, and I just drill you on ACT stuff. Is that good? No. There's 10th graders in here. Does it matter? Is it good for the 10th graders to review ACT questions? As of, by, like, October, you can already start taking it. Alice, are you the only 10th grader in here? Oh, right. But as of October of next year, you can already be taking your ACT if you really want to. So, okay, next part. Now it's getting a little harder. Oh my gosh. We are missing one of the sides of the triangle. What are we going to do? What formula is the most popular formula in geometry? Very good, Riley. A squared plus b squared equals c squared. He wasn't talking to me. He was talking to Parker, but I heard him say that. A squared plus b squared equals c squared. So, isn't the hypotenuse the missing side? So don't we have to find the side? This should be very easy. We need to put it in radical, simplified radical form. We are elite trigonometry students. We do not write it in decimal form. Everybody hear that? We do not need to write it in decimal form. We are in trigonometry. 9 plus 49 equals c squared. 9 plus 49 equals 58 equals c squared. How do we get c alone? What do we have to do to both sides? Square root. I don't know if we can simplify this. I don't know. Isn't this made up of 2 times 29? 2 times 29, right? We need 2 of something in order to take something out. It'd be different if it was the square root of 12. The square root of 12 would be 2 square root of 3, correct, you guys? 2 square root of 3 is the square root of 12. We can't simplify the square root of 58. We leave it as the square root of 58. Can't do anything about it. Can't do much. Can we find the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent of alpha? Where's alpha? Here he is. What I would do if it was me, I don't need to do this, but I think you need to do this. I would write the formulas down first. I would. Here's so. Here's ka. Here's oa. I would write them down. Maybe you're better. You don't need it, but I think it's a good idea to do it. What's the side opposite of alpha? 3. What's the hypotenuse? Square root of 58. I'll talk about that in a minute. I'm not simplifying it yet. I'll tell you why I'm not going to simplify it yet. There's a rule in math that says you can never leave a radical in the denominator as your final answer, right? So I'll worry about that in a minute. Cosine, the adjacent over the hypotenuse. Oa, opposite over adjacent. 3 seconds. I did not simplify anything. I just wrote it down. So far, so good. How do I get my other 3 answers? Flip them, correct? Well, if it looks like this, it must look like this. If it looks like this, it must look like this. If it looks like this, it should look like this. So far, so good. 4 of them are right. 2 are wrong still. Obviously, 2 are wrong. Everybody knows which 2 are wrong, right? These 2 are wrong. Why? There's a radical still in the denominator. I need to simplify it. I need to multiply the top and the bottom by the square root of 58, correct? All right, get rid of the radical. And I'm running out of room. I don't even know where to put this. Isn't it going to be, for the final answer for sine, 3 square root of 58 over the square root of 58 times the square root of 58? Isn't it just 58? Did I get rid of the radical in the denominator? Same thing with this one. I'm just going to write it down. 7 square root of 58 over 58. Final answer. Okay, do you see why I don't simplify it until I flip it? Look what this would look like after I simplify it. Look what happens when I flip it. What happens if I would have flipped this after I simplified it? This would have been in the radical. You would have had another radical to deal with, correct? You need to flip them before you simplify them so you don't have to worry about radicals after radicals after radicals. Got that? Okay, moving on. I don't know what we have left. Oh, we have these left. You guys learned about coterminal angles, correct? Coterminal angles. What are cofunctions? I bet a lot of you know the sine, cosine, tangent. What's the actual word for these? These are just abbreviations, right? Isn't this the right way to write sine? Cosine, isn't this the right way to write cosine? Secant, that's the right way to write secant, cosecant. Tangent, cotangent. Okay, what are these of each other? Sine and cosine are two different formulas. They're the ka and the so and the ka, right? So katoa, right? They're the adjacent over the hypotenuse and the opposite over the hypotenuse. But what do these two have in common with each other? They're called cofunctions. That's why there's a CO in front of it. Cosine, sine, cosecant, and secant. They're cofunctions of each other. And I just want to show you how this works. The sine of 30, which is up here, the sine of 30 equals the cosine. Look at this, you guys. This is on the ACTs. If this is 30 degrees, to find the cosine, it's 90 minus 30. What's 90 minus 30? 90 minus 30? 60. If the sine of 30 needs to equal, the sine of 30 needs to equal the cosine of what? What's 90 take away 30? The sine of what? 60. Let's see if they're right. Take your calculators out and do the sine of 30. And do the sine of 60. Are they cofunctions of each other? Are they same answer? Do you get 0.5 for both answers? Right? I didn't mean sine. It's cosine. Do the sine of 30 and the cosine of 60, and you should get 0.5 for both answers on your calculator. They're cofunctions of each other. I already did it right there. So, if they're talking about cofunctions, it means a totally different thing. If they ask you to find the secant of 50, how do you write this out? Isn't this how you write out secant? Right? What's the cofunction of secant? What's the cofunction of secant? Cosecant, right? How do you abbreviate these? SEC and CSC. These two are said to be cofunctions of each other. If the secant of 50 degrees must equal the cosecant of what? Of 40, right? They have to add up to what degrees? What does it have to add up to? 90. Oh, this is good practice. Do we have either one of these on our graphing calculator? Secant or cosecant? Do we have either one of these on our graphing calculator? Good practice. Let's do secant of 50 first. How do you do secant of 50 on your calculator? What do you have to punch in first? What's the reciprocal of secant? What's the reciprocal of secant? Cosine. So get cosine of 50. Then what do you have to do after cosine of 50? X to the negative 1. What's the secant of 50 degrees? The secant of 50 degrees should be 1.5 something. 1.55555. Let's see if they are cofunctions. Now I want to do cosecant of 40, but we don't have a cosecant button on our calculator. What do we have to put in? Sine of 40. Then what do we have to get? X to the negative 1. Voila, are they exactly the same answer? Are they cofunctions of each other? Yeah. Any questions about cofunctions? They're going to ask us on the ACTs about cofunctions. I'd say there's about 4 to 6 questions on the ACTs. That's 6 points if you didn't take trigonometry. 6 points on the ACTs if you didn't take trigonometry. Okay, last part. Just use your calculator. Let's just do a couple. I think you guys can handle it. Sine of 18 degrees, 22 minutes. Sine 18 degrees, 22 minutes. Sine of 18 degrees, 22 minutes is 0.3151. I think they want you to go up 4 decimal places. Is that what you guys got? Let's go down to this one. Let's do the secant of 45 degrees, 29 minutes. Secant. There is no secant sign. What are we going to use? Cosine. Cosine of 45 degrees, 29 minutes. It's like I'm playing video games. Cosine of 45 degrees, 29 minutes is something. That's not the answer. The answer is 1.4263. Correct? We hope. Any questions on the last part using a calc? I don't think we need to do those other two, do we? You guys know how to use these new buttons on your calc. I think I did everything, didn't I? I taught, and I taught. I think let's just look up here. Let's just do one more of these fun triangle things. Let's do one more. Here's theta. You don't have to write it down. Let's just look at it. This is an 8. And this is 12. How's that? We're trying to find, no, let's make this the 12. Ooh, we're trying to find this side of the triangle. So, a squared plus b squared equals c squared. So far, you guys? Isn't this 144? Isn't that the hypotenuse? Isn't this going to be 64? And aren't you finding either the a squared or the b squared? Which gives you a squared equals 80. This is a good one. Made up a good one. A squared equals 80. Square root. A equals, isn't this made up of 8 times 10? So far, so good. Isn't this made up of 2, and 5? Everybody so far, so good? Take out a 2, take out another 2. Square root of 80 is the same thing as 4 square root of 5. That goes right here. 4 square root of 5. Everybody got that? Now I'm just going to run through sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, cotangent of theta. Really fast here. Sine, here's theta. Sine is this over this. 4 square root of 5 over 12. Cosine is 8 over 12. Tangent is opposite over adjacent. So far, so good? What's wrong with all 3 of these? What's wrong with all 3 of those for the cap? Are they not simplified all the way down? Do we have to simplify them? Isn't 4 twelfths the same thing as the square root of 5 over 3? Isn't 8 twelfths the same thing as 2/3? Isn't 4 square root of 5 over 8 the same thing as the square root of 5 over what? 2. That's the first thing you need to do, is simplify all 3 of them. And then what do you have to do with all 3 of them? Flip them? I'm going to flip this one. This is the easiest one to flip. This one's harder because the square root of 5 over 2 is the original. Cotangent is 2 over the square root of 5. Can we leave that as the final answer? No. This one, flip it. 3 over the square root of 5. Do not leave that as the final answer. Everybody got what I'm talking about? Okay, what's your assignment? I don't even know where we're at here. Right here. Page 288, 289, 14 through 24. It's 11 problems, but every problem has a lot of what? Sine, cosine, tangent, cosecant, secant, cotangent. The more you do this, the better you get at it, but now we're going to switch it on you to do trigonometry in a couple of days. So, okay, that's it. 12 problems to do for tomorrow. 12 problems. Great. I pushed record and it didn't do it, so you guys don't have a recorder. Yeah. Never recorded. I thought for sure Do you guys have your homework handed in? Did you guys hand it in already? Put it up here. Oh, maybe I did record it. It is. I'm still talking.